Okay, so in class today we started dealing with right triangle trig, or trigonometry, and basically we talked about how trigonometric ratios are just these three special names for certain ratios, comparisons of two sides of a triangle. So like the sine always means the opposite side from your angle over the hypotenuse. The cosine always means the adjacent side over your hypotenuse. And the tangent always means the opposite over the adjacent. And again, one of the things we mentioned was the sine of one angle is equal to the cosine of the other angle. See how these are both A over C? Or these are both B over C. Because when you move from one angle to the other angle, your opposite and your adjacent switch places. And since one of those is opposite, sine, and one of those deals with adjacent, cosine, they just switch places. Okay, so on example 1, we talked about using numbers to do this. We just set up the ratio. The thing to notice about example 1 is you have all three sides. You know all three sides. Or you could be in a situation where you can find all three sides. Like maybe if I had 60 and I had 11, I could find 61 using the Pythagorean theorem. So if I know all three sides of the triangle or have found them, then I just put one over the other. I have to make sure I do the right one. For sine, it's always opposite over hypotenuse. So I said for sine of j, I go to j and I figure out which is opposite, which is hypotenuse, and put one on top of the other. And remember that when you were changing that, if you're asked to do that as a decimal, you just take that fractional answer and change it to a decimal. Okay, like 60 divided by 61 in your calculator. You do not press the buttons that say sine, cosine, or tangent for any of this. When you just are looking at the side lengths and setting up a ratio, you do not press buttons that say sine, cosine, or tangent on your calculator at all. Okay? A common error sometimes people make is like they'll say, okay, cosine of j is 11 over 61 because that's adjacent and that's hypotenuse. Okay, great. Now they want me to do it as a decimal. Okay, I guess I better put cosine of 1161, not 11 over 61. No. Okay, just no. You're not doing cosine of this. This is the cosine answer. And just changing it to a decimal just means 11 divided by 61. All right. So down here, we practiced a few more of these. This I know I got through in all periods. We were a little bit limited in 6th period, and that's as far as we went. So if you were in 2nd or 3rd and want to skip this part, let me just tell 6th period folks. The way to do this is where I do get to use those buttons. I get to use the buttons that say sine, cosine, and tangent. Okay, and notice that the difference here is we were not given any side lengths of a triangle. We were given the actual angle measure. Like I was told angle A's measure. Down back here, we weren't told what the angles are. Like I wasn't told if this was 3 degrees or 10 degrees or what. I'm just being told, just let's call it K. But here I actually know the degrees of the angle. So if you know the degrees of the angle and you're being asked for the sine of that angle, you say sine and then punch in 52 degrees. And you get 0.788. Now this says to the nearest hundredth, so I'm going to go to that second 8, 0.788. 7 is the tenths place, 8 is the hundredths place, the second 8 is what I look at. That's the thousandths place. I look at that to decide whether or not to make this first 8 go up or stay the same. It's going to go up, so it's 0.79. So sine of 52 is 0.79. The only reason I did the squiggly lines is because I rounded, so that's an approximate answer. So for the next one, I'm just going to do tan 65. So I just press the tan button, 65. Notice that I'm just pressing the actual button that says tan, cosine, sine. Not the stuff on top of there with that little -1. We will get to that another day this week, I promise. But right now, I'm just finding the tangent of 65. So I get 2.14. The next 4 tells me to keep it the same, don't round up. So it's 2.14. Go ahead and try a few more of those. Pause your video here if you want to try them first and then check. Okay, so sine of 62. You should get 0.8829 and so on. And so when I round that, it's just 0.88. Down here, cosine of 19. I'm sorry, I'm not really going in order. I thought it went across, but part B here, cosine of 19, 0.9455, so it's 0.95. It's okay if you don't put the squiggly lines, but I like to remind myself it's a rounded number. It's an approximation. I'm kind of a math teacher that way. Tan 11, 0.1943, etc. So it's 0.19. And finally, cosine of 30. A funny thing happens when you do this one. So watch what happens on this particular calculator. When I do cosine of 30, I get my answer in a radical, and the reason why is this is one of my special right triangles, a 30, 60, 90. Okay, so a 30, 60, 90 right triangle, I could figure out the cosine ratio with radicals. But if you don't want that here, which we don't, we were asked to do it to the nearest hundredth, I press this little button above the enter to change that to a decimal, and I get 0.866 or 0.87. All right, now, here we are using what we've been doing. This is where we actually get to use it, and this is, we use it to find missing sides of the triangle. That's what we're going to do today. Tomorrow or the next day, we'll get to using it to find missing angles, and that's the only time we'll use those little -1 things. Right now, we're just using it to find missing side lengths, and so what I have to do is for each one of these, first I figure out what is it I'm looking to find. Well, I'm looking to find the length of BC, so this is my x. All right, now, all of these trig ratios are ratios, meaning a fraction. That means I need to figure out what's going on the top and what's going on the bottom. Okay, I have two things I'm working with here. One I know and one I need to find. 10.2 I know, x I need to find. And this is the angle I'm going to work from. If you were given both angles, you could do either way, and of course you could always find this angle and then work from that one. But I'm just going to stick with using the angle they gave me and saying, okay, this is the one I'll look at the triangle from. So if I'm looking at this triangle from angle B, then I am going to say this is the adjacent. Here's the hypotenuse. Here's the adjacent. And here's the opposite. Okay? So I'm not using the hypotenuse at all here. I have the opposite and I want the adjacent. And the trig function or ratio that deals with opposite and adjacent is tangent. So that's how I know which to use. So I'm going to use the tangent, and I'm going to set up that equation that the definition basically is. The definition is basically an equation. It says the tangent of an angle is the opposite over the adjacent. So tangent of my angle is 15. I'm filling in the things I know. Equals opposite, which I know, over adjacent, which I don't know. Now we're just like the proportions we opened our lesson with today. Where on one side it's a fraction, on the other side it's not, but I'm going to make it a fraction. Now I cross multiply to solve this. When I cross multiply, I get tan 15 times x on one side equals, on the other side, I get 10.2 times 1. All right, now let the equation tell you what's going on. My equation says x is not alone yet. So that means I still have more work to do to get x alone before I go anywhere near my calculator. Don't go to your calculator yet. Figure out what you're going to put in first. So x is 10.2 divided by tan 15. When x is alone, that's when I get the calculator out. And I say, okay, this is telling me what to put in. And that's 10.2 divided by tan 15. And I get 38.066, so 38.07. And that's my answer, 38.07. It's feet. I'm kind of out of space, but it's feet. Okay, example 3b. Find the length of QR. That's my x. And remember, please, that you can pause this at any time and go replay a section or skip ahead. Excuse me. Find the length of QR. I'm going to use this angle because it's the one given to me. So for this angle, this is the hypotenuse. X is the opposite because this is the adjacent. So in this particular problem, I'm not using the adjacent at all. I'm using the opposite and the hypotenuse. The trig ratio that deals with opposite and hypotenuse is sine. So I set up my equation, and you always set up an equation. Sine 63 equals opposite over hypotenuse. Every single time you need to set up an equation. Don't try to do it in your head. Well, of course you can't do it all in your head, but don't try to just jump to the part where you put it in your calculator. You need to set up an equation like this. Then you need to actually cross multiply. So we're cross multiplying sine of 63. And you know, that whole thing is like a number. It's like the whole thing, sine of 63 is a number. It's not like 63 is separate from sine. It's all together. Sine of 63 times 12.9 equals 1 times x. 1 times x is just x. Is x alone? This time the answer is yes, so that means I'm ready for the calculator. So I'll do sine of 63, and I'm pressing enter. Here's why. And then I'm doing times 12.9. Let me show you why. If you don't press enter, you have to be careful to do sine of 63, close your parentheses, and then do times 12.9. If you don't close your parentheses, you're going to get a completely wrong answer because the calculator thinks that you want to do the sine of some huge angle that's 63 times 12. So that's what this is saying to the calculator, is do the sine of all of this. That's not what we want to do. We just want to do the sine of 63, and then we want to multiply our answer for that times 12.9. So that's why I make sure to either close the parentheses or press enter before moving on. All right, next, example 3C. This time it says find the length of FD. Okay, so here's FD. Round to the nearest hundredth. All right, so here's angle F is the one supplied to me this time. This side is adjacent. This side is hypotenuse. So for this one, I'm using think about which one is adjacent and hypotenuse. It's cosine. So cosine of the angle, 39, equals the adjacent over the hypotenuse. Always want to set up an equation, and then we're going to cross multiply. So this time we get cosine 39 times x equals 20 times 1. Is x alone? No, it's not. So I need to divide both sides by cosine 39. This tells me what to put in the calculator. And 20, oops, excuse me, I got to clear it out. 20 divided by cosine of 39 is how I'm going to get my answer. 25.73, but I'm going to round up, so it's 25.74. Okay, I should have mentioned this earlier probably, but if you are using a graphing calculator, you may be having a problem. You may be getting different answers from me, and here's why. If you're using a graphing calculator, go in your graphing calculator to mode. It's basically in the same place as it is on this calculator, right next to second. Go in the calculator to mode, and it doesn't say this, well, it kind of does on mine. On yours it says degrees and it says radians. And sometimes the graphing calculators are automatically in radians. You want it in degrees because we're talking about 39 degrees. Don't worry about what radians are, just make sure you're in degrees. That's only for people who are using a graphing calculator. Now, you go ahead and try these four at the bottom. I'm going to stop here, and then I'm going to show you the answers to those in another video. It'll be part B.